All right, what up, everybody? This is Mr. Stan coming at you with another physics video. This time we're talking about how to look at a position versus time graph and find information, and from the information, trace what a velocity versus time graph looks like. So we're translating from position data to velocity data. How do we do that? Well, first of all, you can look at a position versus time graph and you can tell a couple pieces of information. You can tell whether the velocity is positive or negative, or zero, and you can tell whether the acceleration is positive, negative, or zero as well. And with that information, you can draw the right shape of a velocity versus time graph. Okay, so velocity is equal to the slope of a position versus time graph. So that's kind of the key piece of information when you're going from position data to velocity data. When you see the slope of the line, that slope tells you about the velocity. If the slope of the position graph is positive, meaning it's going uphill from left to right, that means you have a positive velocity. If the slope is negative, meaning it's going downhill from left to right, that means you have a negative velocity. And if the slope is flat, like this right here, that means you have zero velocity. The thing's not moving. You can also tell the acceleration. So if you have a curl up, then the acceleration is positive, right? Some people call this a smiley face. Now, your position versus time graph might not have this entire smiley face right here. It might only have a little portion of it, right? So, like if you just imagine it only has the left half, you could just in your mind continue the pattern, and you see it curls up like this, and that smiley face means that you have positive acceleration. Or maybe for a negative acceleration, you only have the right half over here. You just in your mind continue that pattern, and you see it's part of a smiley face, so it must be a negative acceleration. I'm sorry, it's part of a frowning face, so that must be a negative acceleration. Okay, if you see no curl, okay, it could be flat, it could be diagonal, but it's not curling, it's just a straight line. That means that there is no acceleration. Okay, so you would expect there to be, when you translate that into velocity information, you expect no acceleration to be there. Okay, then let's think about velocity graphs. Velocity graphs are the one where the velocity is on the y-axis or the vertical axis, and time is on the horizontal axis. So a couple important things to know about velocity graphs is that a velocity graph, if it's above this middle portion, then you have positive velocity, okay, which means the thing is moving away from the reference point. If the line is anywhere below this halfway point, then that means that the velocity is negative. The thing is coming back towards the reference point. And with velocity time graphs, the acceleration is equal to the slope, which means if the line is sloping upwards, you have positive acceleration. If it's sloping downwards, you have negative acceleration. And if it's not sloping at all, you have no acceleration. Okay, it doesn't mean you have no velocity, but you'd have no acceleration. It's not speeding up or slowing down. All right, so with this in mind, we're going to be able to look at these attributes of a position graph and translate them into a velocity graph using their matching attributes right here. So for instance, if you see a positive velocity on the position graph by seeing the positive slope, then on the velocity graph, you would expect the velocity line to be somewhere in the positive, right? They're not going to look alike. Like for instance, a line that goes up on the position versus time graph doesn't have to go up on a velocity graph, right? But it would have to be in the positive half of the graph. Okay. You would also look at the curl in the position graph, and you can tell if it curls up or curls down or doesn't curl at all. And that would tell you whether the slope of the velocity graph is going to be up, down, or no slope at all. Okay, so let's practice, and I'll show you a couple examples. So hopefully after this, you can do some on your own. All right, so here's our position versus time graph. Right, a lot of times they use the X symbol for position. And let's look at some things we notice about it, right? We want to look at where is the line moving, what type of curl does it have, and how is the slope changing? Okay, those three pieces of information are key to finding the velocity graph. So first of all, where is it moving? It's moving away. Okay, why do I say that? Because The bottom of the graph here on the horizontal axis would be 0. That's wherever the motion is referenced from. So the line, as you go from left to right, is definitely moving away from the reference point. So it's moving away, which means on the velocity graph, which I will wait to the end to show it, the velocity graph should have a positive velocity. So the line should be in the top half of the graph. Okay, second thing we want to notice is which way the line is curling, and it's curling up, right? This is the half of a smiley face, so it's going to mean positive acceleration. And positive acceleration on a velocity graph means that there is a line that is sloping upwards. So we expect to have a line that is in the top half of the velocity graph and is sloping upwards. Okay, and then finally, we want to look at what the slope is doing. And it starts flat, but it gets steeper and steeper. It ends steep. So if you're walking up that hill, it would be easy at first, but then it would get harder and harder. All right, that is a sign that the velocity is getting faster and faster. Okay, so on the velocity graph, the line would have to move away from 0, right? 0 is like the halfway point of a velocity graph, where the horizontal axis separates the positive and negative. It's going to be the line's going to be moving away from that as you go from left to right. Okay, so a line in the top half sloping up and moving away from 0 look just like that. Okay, so take a look at that. Pause the video if you need to. But we found all the attributes of this velocity graph by looking at the position graph. Let's do one more example. This one looks a little different. We do notice that the line is moving away, okay, from 0, right? It's a different shape than before, but because it's moving away, that means the velocity would also have a, the line would be in the top half of the graph because it would be a positive velocity. Right, what about the curl of the line? Well, this one is curling downwards, right? If you continue this pattern, you can imagine that it's part of a frowny face, not smiley face, right? So that means you have a negative acceleration. What would a negative acceleration look like on a velocity graph, right? It would be a line sloping downwards from left to right. Okay, so it's going to be in the top half of the graph. It's going to slope down. This line starts steep and then gets flat. Okay, so if you're like climbing up this hill, it's going to be hard at first, but it gets easier and easier at the top. Right, that is a sign that the velocity is slowing down. It's getting closer to 0. And so the line on the velocity graph is going to get closer and closer to 0. It's going to have to start away from 0 on the top half and slope downwards until it gets closer and closer to 0. So this is what it would look like right there. Okay, and again, we're able to tell all this information just by looking at the shape of the position versus time graph. All right, I'll see you all.